Hello everyone. Welcome to my channel Chemistry is Fun. Today we will be dealing with a new topic, hydrogen bonding, which is a type of chemical bonding. Actually, hydrogen bonding is a special type of attraction which is present between the dipoles. The dipoles are produced within the same molecule or between two different molecules. For example, if you see, let's say there is a molecule like XH, where X is a highly electronegative atom, H is hydrogen. So, because the electronegativity difference is very high, this shared electron pair will shift more towards X. Because of this, a polarity will develop. So, there will be a dipole. So, another molecule of the same compound, another XH. Here also this X is highly electronegative. So, it will develop a partial negative charge. Hydrogen becomes partially positive. In the previous molecule also this is delta minus, this is delta plus. So because of this dipole, there will be a force of attraction between hydrogen and this electronegative atom. This gives rise to hydrogen bonding. Hydrogen bonding tells us about the association of some molecules which are present in liquid state, as in case of water, H2O, H2O, HOH. So here, because of hydrogen bonding between the two different molecules of water, it will lead to their association and we find it in liquid state. In hydrogen fluoride as well as in ammonia, hydrogen bonding is present. This concept of hydrogen bonding was introduced by Latimer and Rodbush. They gave this concept. Hydrogen bonding is present in a variety of hydrogen compounds. That is the compound in which hydrogen is bonded to any other highly electronegative atom. The electronegative atom may be fluorine or oxygen or nitrogen. The bond between the hydrogen and the electronegative atom in the molecule is a covalent bond. Like as in case of hydrogen fluoride, HF. This bond between hydrogen and fluorine, this is a covalent bond. But one molecule of HF will develop hydrogen bonding with another molecule of HF, that is the hydrogen bond. In case of hydrogen bonding, the electron pair between the two atoms in the molecule gets attracted more towards the electronegative atom. Therefore, a dipole will be produced, as I told you. So, there will be a positive end which happens to be the hydrogen part and a negative end. And then, as we see here, hydrogen will be delta plus, the electronegative element which may be fluorine will be delta minus, again another delta plus and delta minus, then a force of attraction develops between the dipoles. We can represent hydrogen bonding in this way. This is the molecule XH. X is electronegative, H is hydrogen. Hydrogen is delta plus because it is less electronegative, whereas X is electronegative, so it is delta minus. X is the electronegative atom, and then between one hydrogen of one molecule and the electronegative atom of the another molecule, hydrogen bond formation will take place. Hydrogen bonding also explains cluster of molecules, like this is XH, XH. So many molecules are there. In between there will be hydrogen bonding. So we find association and as a result cluster formation. Because of cluster formation, we find that H2O, water, is in liquid state. All the hydrides of different elements may not be liquid. Now we come to the types of hydrogen bonding. One is intermolecular hydrogen bonding, that is between two molecules. It will result between the positive and negative ends of different molecules. The molecules may be of the same or different compounds, as we find in case of ammonia and water. Ammonia is NH3, one nitrogen atom linked to 3 hydrogen atoms. Here also nitrogen is having a delta minus charge. Hydrogen will have a delta plus charge. It is same in all the molecules. And with the red dotted lines, you can see the hydrogen bond formation between hydrogen atom of one molecule to the nitrogen atom of the next molecule. So this is hydrogen bond formation here. Hydrogen bonding also can lead to increase in viscosity. As we can see in case of ethanol, here you see it is eta is 1.2 centipoise, whereas in this molecule you see hydrogen bonding will be more because there are two OH groups. Here we find that eta is 17 centipoise. This is the hydrogen bonding shown in case of water molecule. You see these are all HOH molecules, water. The hydrogen part is having delta positive charge, whereas oxygen is negative, partially negative. So there will be a hydrogen bond formation between the hydrogen atom of one molecule to the oxygen atom of the next molecule. Because of this type of hydrogen bonding, there will be increase in the boiling point as well as solubility in the water. Now see, we can explain solubility of alcohol in water via hydrogen bonding. CH3CH2OH, this is an alcohol molecule. The alcohol is having partially negative oxygen atom and positive hydrogen atom. Water molecule we have already seen, hydrogen is having a delta positive charge, whereas oxygen is having a delta negative charge. Here there will be a hydrogen bonding between the oxygen having partial negative charge of alcohol with the hydrogen having partial positive charge of water. We can see with red dots there is a hydrogen bonding formation. This leads to solubility of alcohol in water. Next we have to see intramolecular hydrogen bonding. Intra means within the same molecule. This bonding we find between hydrogen and the electronegative atom, means the electronegative element, its atom will participate in hydrogen bond formation. So electronegative elements atom and hydrogen participate in intramolecular hydrogen bonding. For example, orthochlorophenol. With the benzene ring, there is the phenol group, OH is attached and one Cl is there in the ortho position. So there is a hydrogen bond between the hydrogen of OH group and the chlorine. Now we come to nature and importance of hydrogen bond. It is an electrostatic force of attraction and it involves not more than two atoms. It never involves more than two atoms. The bond energy in case of hydrogen atom is very less than that of covalent bond. Now in case of hydrogen bond, we have seen that there is one hydrogen atom and one electronegative atom. As the electronegativity of the electronegative atom increases and its size decreases, the hydrogen bond forms becomes more and more strong. The strength of the hydrogen bond will increase. Certain properties can be explained by hydrogen bonding. First is because of hydrogen bonding there will be high boiling and melting point. Like we see there is a high boiling point as in case of water. There are many hydrides, but if hydrogen bonding is possible, the boiling point will increase. Water and ice show some unique properties, that is also because of hydrogen bonding. Next is strength of acids and bases. Some of the acids, like in case of organic acids, we call them carboxylic acids. After the removal of hydrogen, carboxylate anion is left out. If the anion is stabilized by hydrogen bonding, the acid from which the carboxylate anion is formed will be more stable. The anion is more stable, so the acid is strong. When the anion is more stable, the acid is strong. Just we have seen the solubility of alcohol in water, that is also because of hydrogen bonding. So a substance is soluble in water if it forms hydrogen bond, that we have seen in the case of alcohol and water. So these are some of the properties which can be explained by hydrogen bonding. I hope you could understand the concepts discussed today. Thanks for watching my video. Please subscribe to my channel. Thank you all.